Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Today we are talking to Dan Berrigan, a digital manufacturing research team lead at the Air Force Research Laboratory. He's a child of science fiction who is teaching robot arms how to multitask.
In 3, 2, 1.
Hi, Dan. Welcome to Lab Life. What we'd like to know is, what do you do for the Air Force Research Laboratory?
No, so I work in our Manufacturing Technologies division, and what that means, and I lead a research team, or we're standing up a research team in the Manufacturing Technologies division to look at digital manufacturing. And that is really, how do we bring autonomy or autonomous systems to the manufacturing process, and what do we learn by doing that? And the reason we might want to do that is to both bring expertise into the robotic materials and manufacturing process, but also being able to capture the data that comes off of these processes, and so that we can help the Air Force make more informed decisions about aircraft lifetimes or part performance or sustainment type questions.
And I can't help but notice that you're wearing a Reading Rambo shirt.
So this is casual Friday wear. Actually, my brother found this online and thought it was totally me, which is LeVar Burton dressed up as Geordie LaForge shooting an AK-47 like Rambo. So it's Reading Rambo. So, it really distills my childhood down.
And don't worry, we'll make sure to get a picture so you can all see this. It is worth viewing yourself.
You can get this online. Anyway, not an endorsement or a sponsorship.
Yeah. So are you a big LeVar Burton fan, or?
I would say he was my favorite. He was one of my favorite Star Trek characters, because he was always the one fixing everything. You know, when anything was gonna blow up, or you know, the ship needed help out of danger, like he had the brain and the smarts to go in and fix it, whereas everybody else was freaking out.
And is that something you kind of look to emulate now, or has kind of inspired you?
I'd say so. I mean, without nerding too much out over Star Trek.
Oh, please.
But you know, it painted a picture of the future that where technology helped us get past a lot of the anxieties and fears, and we go towards more, you know, the machines are helping us so that we can be more curious about the world and universe around us, and put behind us a lot of the stuff that day-to-day challenges and stresses. So it was just this, it was almost like a group of professors go up into space and investigate the universe, right? And there was something about that curiosity and exploration and how technology leads to a benefit to humanity that got me interested in science and engineering. Why I sit here.
To boldly go forward, makes sense. And that's something you used to watch a lot. Are you still a Trek fan nowadays?
You know, when I need to decompress at any point, yeah, it's a good relaxing, you know, turn it on and just let the world melt away and watch my childhood dad, Captain Picard, fix all of the problems of the universe.
It's a good escape, because you do some really serious stuff with your work with the Air Force. How did your career develop? What kind of schooling did you get to come to work for the Air Force Research Laboratory?
I never planned on working for the Air Force Research Laboratory. Actually, I didn't know the Air Force Research Laboratory existed until I was in grad school. You know, I went to undergrad in material science, and as I was starting to graduate, I realized I really liked the research aspects of investigating why things do what they do. And so that kind of led to, why don't I go get a degree or a PhD? And the other reason beyond the curiosity is that I really wanted to, what was most important to me at the time was being able to beat my dad at Scrabble.
That's important.
So the thing was, when I was a kid, we played Scrabble one time, and my dad put down some word. I wish I could remember what it was. I don't know what it is. But he said, you know, I thought that was nonsense. I was like, I've never heard of that word before. I don't get it. So I was like, I want to challenge it. Because he had just scoring like triple word score or something like that. And I said, I challenge that word. He goes, Dan, I have a PhD in political science. You're what, sophomore in high school? are you sure you want to challenge me? And it was at that point, I was like, I need to get the degree. Because then he's never played me in Scrabble since.
Since that
I've
day?
been holding out. Yeah.
After you got the PhD, he's like, nah.
Yeah, exactly.
Yeah.
Because I one-upped him. I did it in science and engineering.
Hey, there you go.
So
Sorry
you,
for all you poli-sci majors.
So you applied to Georgia Tech, and on your essay you wrote, like, I'm applying so I could beat and challenge my dad in Scrabble, basically.
Actually, no, it's a different story. I remember, I remember the essay I wrote. It was actually another reason I wanted to be a scientist or engineer. I remember I had a chemistry teacher in high school who, at the beginning of class or right up on above the blackboard, he had printed out a thing that said, "You have the potential to change the world." And because he was a chemistry professor or chemistry teacher, it attached that potential to science and engineering and math and this kind of stuff. And actually, in my essay, it was all about that inspiration. Now, I got detention left and right in that class, but he was just a great guy, and it's a shit. I mean, anyway, he passed away a couple years ago, and it was a bummer or sad because, yeah, he was a great inspiration to bringing me into science and engineering.
Maybe why we're here today, actually.
Yeah.
So.
Yeah.
And that was something you mentioned that even in your childhood, you'd always been interested in kind of STEM fields, or is that more of a driven power from high school?
It's a good question. I think always from childhood on some level, it always seemed like I wasn't the tinkerer type. I just always wanted to know why or how something worked. And some people like the engineering because they take apart their toaster or they go and take apart their computer keyboard and all. I never did that, but I always was curious as to why this or that were true or why this happened. And so it really, I think, grew out of that curiosity.
So what did you end up writing about for your thesis?
Are you sure you want to keep listeners this whole time? Anyway, it was about protein-mediated layer-by-layer coatings. So using proteins to deposit inorganic materials. So mimicking how shells create, or essentially seashells create their ceramic, essentially, structures. And they can create these intricate structures. How do we replicate that in a more synthetic kind of way? And so I use those coatings to then make solar cells out of them.
Oh, wow.
And looked and investigated their performance and relayed back to why why this process was different than other processes that were used to do that.
So with your thesis then, are you still doing work tied to that now?
Absolutely not. So, and usually, right, you think about somebody who went to graduate school, gets a PhD, usually their subsequent research and job builds off of that degree. And really, I think for me, the degree was more of a lesson in how to conduct scientific research and how to do the research process than it was the specifics on solar cells and energy and all of that. When I came up to the lab, continued some work on solar cells, and then we got out of that. It started to move more into more higher maturity, and we wanted to get into more of 3D printing of materials. And so we stood up or built an entire lab on about 3D printing and how to 3D print arbitrary materials. So a lot of the 3D printers, if you go buy one on Amazon, it's essentially a hot glue gun put on a robot stage. But how do we go beyond those types of materials? How do we go to materials that the Air Force would care about? Higher temperature, have electronic performance, so you can 3D print electronics. That became more of my work at that point. And then that led to where I'm at now, which is broader than additive manufacturing or 3D printing and more digital manufacturing. So if I have a computer controlling a robot, whether that robot is an articulating arm, or a 3D printer, or a milling machine, a CNC milling machine, all these are computer-driven. Somebody inputs a file or gives the machine directions, and it goes and manufactures some product at the end. And so automation is great from the standpoint of if I'm making 1,000,000 of something and I have to teach the robot how to weld a car door on the side of a pickup truck, and I'm making 1,000,000 pickup trucks, I only have to program it once and it's just doing the same repetitive process. But in the DoD, we don't buy 1,000,000 of something, we might buy 20 of something or 30 of something, and then it's 30 of something different, and then it's 50 of something different. And so from a manufacturing-based perspective, that can be challenging, and it can cost us as taxpayers, it can be more expensive because we don't get to capture as much of that economy of scale that an iPhone gets to benefit from. And so how do we make the automation more amenable to different tasks? So one day it might be drilling holes for an aircraft, and the next day it might be printing circuits, or the next day it might be doing some other task that for a product that somebody is manufacturing for us. And so that's a real challenge. It's a lot of programming burden, and it's a lot of questions of how do we bring more flexibility to the computer system and a robotic system in a physical sense.
And are you working with the arm specifically, or are you one of more the programming side?
It's a little bit of both. They're both linked together. And so what we're looking to do is pairing a manufacturing process with, say, a robot arm. So say you were drilling or machining a part out of steel or aluminum, and you were to, say, mount that on an articulating robot arm. So imagine your own arm and having a drill on the end of it. How do you program that to do what you want? Make sure that what you just machined out is exactly the specification that we need. And then maybe beyond that, how do we learn from that process? So the next time another billet of material comes in and maybe it's a different design, but maybe you learn that, when I tweak my arm to the left, the drill bit does something something I didn't intend. How do I learn from that for the next time? Right now, an expert knows how to do that or remembers that, but how do we impart that expertise into the machine so that it can help aid a novice machinist to become more of an expert machinist? So that's from the manufacturing sense. You see that in robotic assisted surgery. So in the medical community, they're working on training robots to understand how to do sutures from experts so that a novice surgeon can perform surgery like an expert, right? So that helps everybody, right? And it's how do you link those sensors with data with the human? How do we connect those dots? Because it's not going to be all robot. There's going to be some human interaction.
Yeah, it sounds like you would really need like a diverse team education-wise or field-wise to pull this off, because you're talking about manufacturing and computers and programming, and it's all over the place.
Absolutely, yeah. It's roboticists, it's data science, it's manufacturing and material science, because you need to understand the interaction between that drill bit and that material set, and somebody who's a roboticist might not have that in-depth intuitive understanding of how those materials interact. And so it's a very, and that's really, to me, I would say in science in general, it's the intersections that are really the seams of all these different disciplines is where cool stuff happens. It's when you start to get, a roboticist in the room with a biologist and a chemist or material scientist with a computer scientist, and that's where the crazy ideas start to happen. So
sounds like an interesting team to lead with a big impact for Air Force.
I hope so. We're looking to connect with the logistics centers, right? Because they have a lot of the internal manufacturing cells. So they do a lot of support for taking care of Air Force assets, right? So plane comes in, it needs maintenance and updating, or the different manufacturing processes. If you want to repaint an aircraft, you go there, right? And so how do we bring some of these robotic tools to bear on Air Force logistics, from the Air Force logistics side? And they're interested in it from the safety, to improve safety. So that way their people don't have to go into different dangerous environments or potentially dangerous environments. Really, the logistics centers are looking at it to improve safety in the maintenance and sustainment of aircraft.
And you kind of touched on it, but is that where you kind of see this going the next, even let's say 5-ish years, much more of a safety focus, or really could take any life of its own depending what you find?
I think the safety focus is really what we're doing now. And in 5 to 10 years, it's how do we impart closed loop feedback, and so that if something happens during the manufacturing process, can we fix it? Or can the machine automatically detect and fix it? Can we impart that knowledge from an expert into the machine itself? And so that way they can help, the machine can help guide the process and help the expert improve the decision making of an expert.
Yeah, and a lot of people, this is kind of almost like a fan question, you could say, because this is what most people bring up with things like this. So the idea is not to have a machine, let's say, replace someone's job, but be working in tandem, so they can almost be partners.
Robots are really good at doing the boring stuff you don't want to do. You know, filling out my travel voucher. Man, I wish a robot could do that, right? And that would free me up tremendously to go think about these more creative, the more abstract concepts and the things that involve critical thinking, and really those are the things that we'd love to do more of, right? And so yeah, it's not, I think think of Siri and these different voice assistants, right? They help you make things take less time, and I think that's really, but they still need you to engage and be part of the process. And so I think that's where that boundary happens. I don't know, but it is going to be, I think it'll be a mix.
Something exciting for the future, definitely. And if they could fill out my travel voucher, that would be great.
I love that.
Just throw that into your mix for us.
I will.
So we've kind of gotten a slice of you, Dan. I know that we can talk about so many crazy things you've done within the Air Force we haven't even touched in this episode, but if you could help someone along, a student that wants to kind of go on your career path to help make a difference or change in the world, that they're in that chemistry class, looking at that sign, what advice would you give them?
Love this question, and the reason I do is because I think in looking back, so I've done a bunch of crazy stuff, you're right. So I never thought as a scientist I'd be doing YouTube videos for the lab, or helping with AFRL Inspire. And I think the advice that best distills something I saw on YouTube, which usually is half the stories I tell involve some video I saw on YouTube. But it was an interview with Steve Jobs. And Steve Jobs said, the most important thing you can understand is that all of the rules, all of the things that constrain people are all made up by people that are just as smart as you are. And you can change it. You can influence it. You can bend it to different directions, and shouldn't let it be always this static, constraining idea. So the idea that if you go to a PhD and you always have to do protein-mediated deposition for solar cells, that's kind of a rule, right? Or at least an implied kind of rule. That's nonsense. Doesn't have to be. Because you're a scientist, you can't go run around with cardboard cutouts in the back of your car and talk to them like they're real. You can do that.
I've seen it done.
To various degrees of success, but you can do it. And it's so much more fun that way. And I've definitely appreciated the flexibility that this place has given me to try those different things.
So Dan, thanks for joining us today. For our listeners, if they'd like to hear more about some of the products and videos that you alluded to, they can check out the Air Force Research Laboratory on YouTube, or even follow us on any of our handles at AF Research Lab.
And remember, stay curious.
Logging off.